coming out in my presentation. Thank you for the invitation to Modular. I'm really happy to be here as a Mexican, sharing this knowledge that we are generating in our company in Vector in North America and also in Germany. So all this information, those are big trends in the automotive industry. All the CI/CD stuff came pretty much from the IT side of things. So new customers or new guys, new players building vehicles like Tesla, Slay, Lucy, Zeus, all these companies are pushing about all the CI/CD environment, right? Because they got a huge and strong background in the IT technology. So for sure the automotive industry is dynamic. It's always trying to improve and install new features and new technologies. And part of that is SDV. We have been listening all this day, SDV, what the SDV concepts are, as software-defined vehicles. Okay, in this presentation, we will go a little bit in depth. What is the infrastructure that we require to implement this SDV process? So in this case, I will check the side of the testing side of things, but it could be applied as well for design, okay? We are treating everything as a code. Everything is code right now. We are reading off of the previous tools with GUIs and all these. The main reason is because we want to automate it, okay? We want to be more agile in the development process and do continuous integration. So that being said, with a text-based code, this is easier. It's easier to compare files, easier to track files, easier to handle all these files as a text, okay? Even complex simulations could be run with text-based code, okay? That's pretty much the idea of the presentation. So I will start with, most of you may know the process to do development, even in an ECU, in a software, a hardware. So what we're trying to do here is the concept to shift all the tests to the left side of the process. So the right side of the process is where we have the requirements, the initial requirements, how to design an ECU, how to design a vehicle, how to design a software, okay? But in the past, it was really hard to test in that phase. So right now, we got a set of tools and infrastructure that you could utilize in order to do tests in the early phases of your design, okay? So for instance, in the left side of the process, we got tools like a DaVinci configurator, VectorDay, kernel for software server edition. Those are part of the infrastructure that I was talking about, how the SDV is implemented. So in that side, we call software in the loop testing, okay? We could test our virtual ECUs just with pure software, okay? When I'm talking about virtual ECUs, it's a really interesting concept because the real ECU that you will have running in the car, now you can make it virtual, just with software. In a Windows environment, it could run in a DLL. In a Linux environment, it could run as a SO file, okay? So yesterday, I had a meeting with some of you guys, and you were asking like, hey, how important is to have virtual ECUs at this moment? So it's really important. It's a big trend. A lot of OEMs are asking right now to tier ones to develop virtual ECUs. Why? Because they want to build a virtual car before to get any hardware ready yet. Okay? So it's a big trend. I'm glad that you guys are involved now in the virtual ECU building. Okay? And that you got this knowledge right now because this is the moment to start working on this. So one of the concepts that we will check here is all the work that you do in front of the process, doing testing of these virtual ECUs, all this work could be reduced when you have already the hardware. So that is the advantage. For managers, for directors, for people that is interested in what is the benefit out of this. Not only the technical side of things, right? Well, the benefit is your process will be more efficient, right? Because you will bring tests in front of your design, even if you don't have any hardware yet. Then all that work could be reused pretty much 100% when your hardware is done. So that saves a lot of time doing development. Okay, I think I did it before. So the strategy that we are showing here is pretty much, we will test at different levels. The software, we will test the static analysis, unit testing, building, but the important thing is a system level. So the system level of a virtual ECU, it's pretty much 95% accurate of the close that you will be here in the real ECU. So which is really important. So talking about the ECUs, how the ECUs are built. So one of the tools that we have is the virtual target that builds these virtual ECUs for you. And you will interconnect these virtual ECUs in many different ways. The important concept here is to understand that these virtual ECUs could run in a local machine, in a server, in a cloud, multiple servers, multiple instances, okay? So that means that you will have all your tests with a big scalability. So in the past, we were saying like, oh, I need to test this virtual ECU or this ECU, and it will take a week, right? Because it's the time that takes to test. Right now, you could run in parallel multiple ECUs with different tests, and then overnight you get all the results that you had in the past in a week. So that's the power of this. Okay, so you could run in different containers, different virtual machines, different locations. Like you could have servers locally, servers in India, or Amazon servers, commercial servers, running your instances. Okay? Perfect. Now, that was a virtual world, right? So all that efficiency is not living there. So what happened when we got a real ECU done? So all the work that you develop in order to test your virtual ECU, like I said, the virtual ECU is 90% accurate to the final implementation in the real hardware. So the advantage of this is that means that the 95% of the tests that you develop in the SIL side are reusable here in the HIL side. Okay? You're using the same files, the same set of tests in order to test your real hardware. And basically, this is the idea here. So we got our pipeline automated where multiple developers could be committing changes from different places to the pipeline and validate and test all this process in an automated way. Okay? So every time a developer commits a change in this pipeline, so it's execute automatically all the building process and the test. So just imagine that. So you are a developer with your pipeline done, you do the changes, and the system it will test your changes automatically. Okay? This is a huge impact in efficiency and automation. Okay, and this is implemented, this is working, this is not like, oh, this is the future, we're going there. No. It is implemented. Okay, so going a little bit technical here just to show what we need to do in terms to reduce all the code that we developed for testing. So in the left side, we got the software in the loop solution and how this works. So we got our virtual ECU level 3, which is the 95% accurate to the real ECU. And in the right side, we got our real ECU, and we have hardware already. So you may notice here in our test environment, which is GNU, we have already the test suite that we developed in the SIL side, which is pretty much the same that we will be reusing in the HIL side. These two processes in the real world, those are like months apart. Those even are different departments. There is people in the same company, they don't even talk each other. Never. I've been there before with different companies. Okay? So the guys from software testing never talk with the guys with hardware or system testing. Never. So the guys on the hardware side, they're always struggling. When the hardware is ready, oh, we need to develop all those tests, starting from scratch. When all those tests were already done before, somehow, this is the connection, and this will save a lot of time. Okay? For sure, we need to adapt something. It's not magic, right? So the connection of the virtual ECUs could be connected inside GNU in some way. And it's the only layer that we need to change or adapt to. Instead to connect to your simulation, you will connect those to input or outputs that they are real. Okay? That simple change will utilize all the code that you develop at the beginning. And this is the big topic that I want to share with you. Perfect. So I was mentioning before, I will be a little bit technical here, but we're treating everything as a code, like I mentioned. So this one is the design of a configuration of a simulation treated as a code. Why code? I explained that it's easier to control, easier to track, easier to compare, and this is a very complex configuration. But you can see where we have your XML files, different modules running, different DLLs, different simulation nodes, different ECUs inside the configuration, everything as a code. This is a YAML file that we use to connect all the toolchain from vector to do the automation. Okay? One simple example here. So we got people working in a test, people working in a software development. Some of those guys are doing changes, okay, in one line of code. Then automatically the pipeline will execute the change, and it will execute the building process of this virtual ECU, and it will execute the test as well. So you can see in this example, line 52, we were running in an Amazon server. You could run it in a local server, you could run it in multiple servers. All these are related. Okay, I got a little bit of demo how GNU for Software Server Edition works, because it's a headless tool. This is not GUI anymore, where you need to configure manually all the panels, all the files that you need to load. This is all text-based, okay? And as a vector, we offer 4 different extensions inside Visual Studio Code in order to support all this testing. Those are for free, those are available right now, and those are the 4 that you see in the top. Vector couple, simulation and testing environment, test unit, vector VCD. With those extensions, you will be able to build your environment to do the test. Okay? So in this case, I'm loading Canonical Software Server Edition. Okay? I go to the set of tests that I have. I have a set of tests already defined there. It will take a couple of seconds to load it. Then you should see in the center that Canonical Software Server Edition will start running and executing the test automatically. These happen every time that the developer make a change in one line of code. Okay? And this process is fully automated. You will see the test, will see the test results, and you will even see the report, like Canon generates the report. Okay? This example is running in a local machine, but all these could be in a cloud. And we will see some slides going later. It's still running 39 seconds. Yeah, and it's executing the test there. You will see the verdict in the right side. And that simulation is running in a local machine that is in the back there. Okay, so if we click on the report, we will be able to see the report of that test. For sure, all these will be automated as well for demonstration purposes. We are opening in a GUI just to show you that is the report that we usually generate with Canvas. Okay? So this is the SIL side. So this strategy, this set of tests works across for HIL. So you don't need to do anything else. These tests are reusable, 100%. Okay? So this is the demo that I was planning to do here today. So we just ran the first use case here at the left. We could still check it out in the middle, but we want the third use case, which is the HIL tester. Unfortunately, we couldn't get the hardware past the customs here in Mexico, so we don't have the hardware here to show it. But next time, I promise. So, okay, how we build pipeline. So pretty much, we are using a set of tools to do all this automation in the background. So this automation involves the infrastructure that I was talking about before, related to the DevOps, SDD. What does that mean? So this is what this means, okay? This is how you build the pipeline, do the automatic test on every commit of your software. And this could be deployed by any developers around the world. That's the advantage. It's scalable, secure, and very powerful. This is how the demo will look like running in a GitHub repository. You guys could utilize GitHub, GitLab, Jenkins. It's open. So if you already have some pipelines implemented, could be easily integrated because all this is standard. Okay? Perfect. So one of the advantages to build this type of systems is, okay, I could build multiple CCUs, multiple simulations, and run those in parallel. And run those in China, in India, Mexico, at the same time. Why? Because you will have different instances running at the same time. Different developers participating in those instances, different tests. So this is the potential that these technologies have. So also, you could deploy the tests that you want to do. Those could be multiple different tests, multiple different type of tests. You are not tied to one set of tests because you have only available one hardware, for instance. In this case, you go multiply the virtual CPU by the instances that you need. Okay? Perfect. So also you have access to what do you want to control and this set of tests. So you can build your own sequences, and all this is text-based. You can see that it's an XML file that is easily controlled inside the PS Code with the extension that we offer already. Perfect. So let's check the summary here. So I talked a little bit about the advantages that we could have here with automation, right? So in this case, this automation works for developers in the software, embedded software side of things, or developers on the testing side. Same infrastructure, same methodology, working with two different types of developers, which is another advantage. It's efficient, and it's really reliable. Okay? So, like I said, we treat everything as a code, we do simulation as a code, we utilize the same set of tests at the SIL side, but at the HIL side, which is the main advantage that I could tell, okay? And we got the parallel testing, I mentioned it already, independent units, and even with all that, you could still have the detail on each pipeline. All the detail is Google tracked. Every little change in your code is tracked. Every little change, you could go back to the previous version and have the history there, which is a huge advantage for developers. Okay? That is my final slide. So I think I'm in time. So I would like to say thank you to all of you. I'm really proud to share this information here with you guys, and that understand that you guys are really in-depth in the virtual CPU world. I've got a question here.
So you talked about scalability. What about licenses in such scalability?
Yeah, that is a great question. And so licenses, in these type of cases, we got different options, either by agent license, which means every instance has a license, or if it's a big project, we got the option to get a big one license for whole project. Doesn't matter how many instances you're running there. In order to check those details, we could get in contact. Yeah, but those are the main two options. Well, good question. That being said, thank you guys very much.